Okay, so for this one is with the graphing calculator, and I just go ahead and graph it. Obviously before this point, it's less than 0, and we have to check here because it looks like that little bit's under. So let's go ahead and find the 0 first here. So we have that x greater than so x is greater than negative 2.30. But this is an asymptote because of the dividing by x. So that's up until 0. And because it's not exactly equal to 2.3, negative 2.3, I don't put an equal sign under that. And then let's zoom in to this bit. Yeah, see? So that little bit is under the x-axis. So if we do from here to here, that's 1. So, or 1 to 1.30. All right, so for 27, solve the inequality that given that one of the zeros of the function is x equals 1. So if we get the same denominator, we're going to have x cubed minus 4x plus 3 all over x. And we know that x equals 1 is a 0. So we can divide, so if we do synthetic division, and we're going to have 1x cubed, no x squareds, negative 4x, and 3. Bring down the 1, and then multiply 1 by 1, which is 1, and then add 0 and 1. And then this one times this one is 1. And then add negative 3. And then this one times negative 3 is negative 3 and 0. So this thing changes. Where it was x cubed, now it's going to be x squared, and we have that x minus 1 went into it. So we have x squared plus x minus 3, and then that's over x. If you were to check x squared plus x minus 3, the discriminant, that's b squared minus 4ac. Okay, so that we need, okay, I was thinking that it was either above or below above the x-axis. It's not. So this is equal to 13. So in the quadratic formula, we're going to have negative b plus or minus the square root of 13 all over 2. So we have the zeros for this are going to be at 0 for the denominator, and then at 1 for the numerator, and then we're going to have negative 1 plus or minus square root of 13 over 2, which, let's see, so square root of 13, let's say, it's definitely in between 3 and 4, closer to 4. So if we do negative 1 plus 4, that's a little bit over, divide by 2. So negative 1 plus about 4 is over 1. It's going to be 3 over 2, so 1.5. So it's over here. So we'll do negative 1 plus root 13 over 2. And then if we do negative 1 minus 4, which is negative 5 over 2, so it's going to be over here. So negative 1 minus root 13 over 2. And then we need to check these. So I don't know, I'm going to do like negative 5, okay? And then negative 1, and then 1/2 here. And then, what is that? So maybe 1.1 here, and then we can do 5 on this side. Okay, so those need to go back into this thing to see whether it's positive or negative. So we're going to have a negative, for negative 5, we're going to have a negative times 5. So positive over a negative. So this is going to be a positive here. If we do -1, we're going to have a negative, and then that's going to be a negative over a negative. So that's going to be a negative in here. If we have 1/2, we're going to have a negative and a negative over a positive. So that is going to be a positive here. 1.1 is a positive. And I think that's going to be a negative over a positive. So this will be negative. And if we do 5, we're going to be positive, positive over positive. So if we want when this is less than 0, it's in between -1 minus root 13 over 2 and 0. Or we have in between 1 and -1 plus root 13 over 2. All right, this one, find the largest set of values of x such that the function f takes real value. So that means we need what's under the square root to be greater than or equal to 0. Otherwise, it's going to take on complex values. So our zeros are at 3, and it can't be 3, and 1/2, which it can be 1/2 when we set the numerator equal to 0. So we're going to check 0, 1, and 4 into this thing. So 0 is going to be a positive, just into there. 1 is going to be a negative, and 4 is going to be a positive. So we've got x less than or equal to 1/2 or x greater than 3 for A. For B, find f at 1/2 and hence write down the range. Okay, so we are going to do 8 times 1/2 is 0. Well, it's 4 minus 4 on top over 1/2 minus 3, which, whatever, it's 0. And hence find the range. So because this, I'm not sure what it means, hence write down the range, but because this is a square root function, what comes out is always greater than or equal to 0. So that's our range. And for CI, the vertical asymptote is when the denominator is 0, so x equals 3, and double I should be the square root of 8 because it's the coefficients. Okay, 29, we've got f and g. Find the values of x for which f of g is less than or equal to g of f. So f of g is going to be 2 times x over x plus 1 minus 1, and we want that to be less than or equal to g of f. So 2x minus 1 over 2x minus 1 plus 1, so just 2x. All right, so let's do this down a bit, getting the same denominator here, so minus x plus 1 over x plus 1, and we'll subtract 2x minus 1 over 2x, and that's going to be less than or equal to 0. So this one together is going to be 2x minus x, so x, and then don't forget to distribute that to the to the 1. So that's x minus 1 over x plus 1 minus 2x minus 1 over 2x. And if we make the same denominator here, we need 2x and 2x and x minus 1, x minus 1. So it's going to be 2x. No, this should be x plus 1, sorry. X plus 1. And we're going to have 2x squared minus 2x minus, and then distributing this out, we're going to have 2x squared plus 2x minus x, so plus x minus 1, and that's less than or equal to 0. And then these will cancel, and we'll have negative 2x, so that's negative 3x up top plus 1 over 2x x plus 1. So our number line, we've got zeros at 0 on the denominator, -1 as well. And then here it's going to be 1/3, and it can be 1/3 because that's the numerator. So if we do 1/4, 1, -1/2, and -2, and see what's going on in here, we'll have our answer. So -2 is going to be a positive over a negative times a negative. So this is positive. -1/2 is going to be a positive over a negative and a positive. So this is negative. 1/4 is going to be a positive over a positive times a positive. So positive here. And 1 is going to be a negative over a positive positive. So this is a negative. So we will have it's less than 0 in between -1 and 0, or when it's greater than or equal to 1/3. All right, this one's divisible by that. So we can substitute in 1, and that's going to be 0. So we'll have 0 equals 1 minus 4 plus 3 plus a. So that's -3 plus 3. So a is 0, actually. So we're going to have now f at x is x cubed minus 4x squared plus 3x. And we can factor out an x. So x squared minus 4x plus 3. And we have x minus 3, x minus 1. So that's b. And solve the inequality that less than 0. So we want this less than or equal to 0. On our number line, we're going to have 0 for this, 1 and 3. So we'll do 1/2, -1, 2, and 4 into that thing. So this at -1 is going to be a negative times a negative times a negative. So this is a negative. 1/2 is a positive times a negative times a negative. So positive. 2 is a positive times a negative times a positive, so negative. And 4 is a positive. So less than or equal to 0, we're going to have x less than or equal to 0, or in between 1 and 3. Okay, this one we are doing the same as last. It's divisible by x minus 1, so we have f at 1 is 0. So 0 equals 1 minus 2 plus 1 plus a. So a is again 0. So b, we have f at x equals x cubed minus 2x squared plus x. Factor out an x. And factor. So we're going to have, that's b. So for c, we want this less than or equal to 0. So on our number line, we're going to have 0 or 1. So if we check out -1, 1/2, and 2, this thing's always positive because it's squared. So negative, positive, positive. So it's all x is less than or equal to 0. Or x equals 1. So this one, we have f at 1 is going to be 3. So we have 3 equals 1 plus 1 plus 1 plus a. So a is, again, 0. b, so we're going to have f at x equals x cubed plus x squared plus x. Factor out an x, x squared plus x plus 1. And we can't factor that, so we have to use quadratic formula. So negative b plus or minus square root b squared minus 4ac all over 2a. So you see under the square root is negative. That means there's no x-intercepts. So that means this is always positive because if there's no x-intercepts and it's opening up because that 1x squared, it's like that, okay? So we just have 1, 0, which is when we want to solve this for less than or equal to 0. For C, we have only time it's equal to 0 is at 0 from this thing. So we need to check on either side, negative 1 and 1. So if this thing's always positive, this is a negative and this is a positive. So we just have x is less than or equal to 0. All right, 33. So we have f at 1 is 0. So 0 equals 3 minus a. So a is 3. So for B, we have f at x is 3x cubed minus 3. And we can divide this by x minus 1 to give us a quadratic. Long division, nah. I was gonna, but it's just too easy. So 1, and then we have 3x cubed, 0x squared, 0 x's, and our constant's negative 3. Bring down the 3, 3, 3, 3, 3, 3, 0. So that means this is equal to x minus 1 and 3. I'm going to pull out a 3, obviously. And that's dividing each of these by 3. If this was x cubed, this is turning to x squared. So we're going to have x squared plus x plus 1 when each of those is divided by 3. So we already went over last time that this is positive. So now at, we only have 1, 0 at 1, and we want this less than or equal to 0. So now we need to check before at 0 and after at 2. So like I said, this is always positive. So if we substitute in 0 here, it's going to be negative, and 2 is going to give us positive. So our answer is x is less than or equal to 1. Okay, we've got F, G, H. Find the equations of all the asymptotes. So for A, I, f at x, we need to factor that denominator, and that's going to be x minus 4, x minus 1. So the asymptotes are x equals 4 and x equals 1. For double I, we need, all asymptotes. That's the vertical asymptote. Horizontal asymptote, degree top is less than degree bottom, so it's y equals 0. Same vertical asymptotes for double I, and horizontal is going to be the ratio of the coefficients because it's even degree. And for triple I, we have same vertical asymptotes, but we have to divide to get the slant asymptote. And I am going to do long division here. So x cubed minus 5x squared plus 4x plus 12. So x cubed minus 5x squared plus 4x, that's all 0, so bring down the 12. So this is going to be equal to x, which is actually our slant asymptote, plus the remainder over x squared minus 5x plus 4. Okay, so now B, express f in partial fractions. So for f, we're going to have a over x minus 4 plus b over x minus 1 equals to 6 over x minus 4, x minus 1. So 6 plus 0x, okay? So getting the same denominator, we're going to have ax minus a plus bx minus 4b over x minus 4, x minus 1. So now we have the coefficients of the x, a plus b is equal to 0, and we have negative a minus 4b is equal to 6. So A is negative B. So we've got negative B, so positive B here, substituting that one. Oh, I can just, let me just eliminate. So it's plus. So that goes away. B, so this is negative 3B, and this is 6. So B is negative 2, and that means A is positive 2 when you would substitute it in here. So that means we can rewrite that as 2 plus a negative 2. You can also do this with the cover-up method, okay? All right, C, which is G. Express it in the form that. So if we factor that top, which can't be factored. Okay, so no factoring. We can just do x squared minus 5x plus 4 plus 6, splitting that 10 up. And then we'll have x squared minus 5x plus 4. Now we can split the numerator up. So it's going to be x squared minus 5x plus 4 over x squared minus 5x plus 4 plus 6 over x squared minus 5x plus 4. So we're going to have 1 plus 6 over x squared minus 5x plus 4. So DI, it says, G, we want to express G in that form. So 1 plus, and we already know from B that that's going to be 2 over x minus 4 plus negative 2 over x minus 1. And then double I for D, H. So this is going to be x plus, this is 6 times 2. So we're going to have 2 times 6 over x squared minus 5x plus 4. So that's x plus 2, and then we're going to have 2 over x minus 4 plus negative 2 over x minus 1. And they want it distributed. So we have E is going to be 1, and then C is going to be 4, and then that's going to be negative 4. All right, solve the inequality. 5 f at x, so 30, less than or equal to 3g. Okay, so we need to get this thing, onto the other side. It's got the same denominator, so we're going to subtract all of that. And that's going to be over x minus 4, x minus 1, and that's less than or equal to 0. So 30 and then minus 30. That will go away when you distribute that 3. So we're going to have negative 3x squared plus 15x over, and factoring out, we'll do negative 3x, and that's just going to be x minus 5. So now we have several zeros. We have 0, 1, open circle 1, open circle 4, close circle 5. So negative 1, 1/2, 2, 4.5, 6 into this thing. So we're going to have a positive times a negative over a negative times a negative. So this is going to be a negative. 1/2 negative, 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 negative. So positive here. 2, negative, 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 positive. So this is negative. So 4.5, negative, negative, positive, positive. So this is positive. And 6, negative, positive, positive, positive. So negative here, less than 0. Okay. X is less than or equal to 0. Or it's in between 1 and 4, not including either. Or, whoops, X greater than or equal to 5. Okay, last one. Find the quotient and the remainder of long division. So we've got x squared minus 6x plus 8 into x cubed plus 0x squared plus 0x plus 50. So x, and that's x cubed minus 6x squared plus 8x, subtract. So 0, positive 6x squared, negative 8x, bring down the 50. So negative 6x, so this is going to be plus, wait a second. Okay, 1 second, 8x, 0, 6x squared, so, oh, okay, yeah. So plus 6, so we've got 6x squared, minus 36x plus 48 to subtract. So 0, negative 8 plus, oh wait, yeah, negative 8 plus 36 is going to be 28x. 50 minus 48 is plus 2. So that A is going to be, goes in x plus 6 whole times, plus, factor out of 2, 14x plus 1, that's our remainder, over x squared minus 6x plus 8, which I'm going to factor. So x minus 4, x minus 2. So quotient is x plus 6. Remainder is 28x plus 2, or the 2 times the quantity 14x plus 1. Hence express. So I've just done that. Well, kind of. This should have been left as x squared minus 6x plus 8. But then for C, and also I shouldn't have factored that, but that's fine. For C, write down the equations of all asymptotes. So that means we're going to have y equals 0 because the degree of the top is 1 and the degree of the bottom, no, it's not. It's a slant asymptote at x plus 6, sorry. And then the vertical asymptotes are at x equals 4 and x equals 2. Okay, D, last thing, we want f at x. So this is f at x here. X plus 6 plus, all right, I'm just going to write it back out. 20, that over x minus 4, x minus 2. And we want to write that in this form. So x plus 6 plus a over x minus 4 plus b over x minus 2. So we'll have ax minus 2a plus bx minus 4b over x minus 4, x minus 2. So the coefficients of the x are a plus b, and that's going to equal 28. And the the constants are negative 2a minus 4b, and that's equaling 2. And so I think I'm just going to multiply by 2, and this is 56. And then I'm going to add. So 2a plus a negative 2a is 0, 2b plus a negative 4b is negative 2b, and 56 plus 2 is 58. So we're going to have that b is negative 29. So that means that A plus B is 28. Remember, A plus B is 28, and B is negative 29. So we have A is 57. So finally, this is x plus 6 plus 57 over x minus 4. And B is negative 29 over x minus 2. And just let me know if you've noticed several mistakes in the mark scheme, because I have, but I think I'm right.